Hello students, welcome back. In our previous lecture, we have dealt with circular permutations. In today's session, we are doing one more concept, that is combinations. So as we know the definition of combinations, that is the different groups or collections or selections that can be formed out of a given set of things by taking some or all of them at a time without considering the order of arrangement is called as a combination. The number of all combinations of n distinct things taken are at a time is denoted by the formula NCR, which is equals to n factorial divided by n minus r factorial into r factorial, where r value is less than or equals to n. Students, we know the definition of combination where the order does not matter. The word combination is generally used for selection of things and the word permutation used for arrangement of things. Do remember this statement. Now see the properties of NCR. We have to just remember by practicing. That is, first one is NCR is equals to NPR upon R factorial. Second one, NC0 is equals to NCN, which is equals to 1. Third one, NCN minus R is equals to NCR. Fourth one, if NCR is equals to NCK, then either R is equals to K, otherwise R plus K is equals to N. Fifth one, N plus 1 CR can be represented as NCR plus NCR minus 1. Sixth one, NC0 plus NC1 plus NC2 so on up to NCN can be written as 2 to the power n. Seventh one, NC1 plus NC2 plus so on till NCN, the same previous formula, can be written as 2 raised to n minus 1. The sixth formula starts from NC0, so its value is 1. So shift it to RHS and start the seventh formula with NC1. You will get the RHS as 2 raised to n minus 1. And some more formulas we have, students. If there are n points in a plane, out of which k points are collinear, then from this statement we can divide two formulae. They are number of straight lines that can be formed using these points is NC2 minus KC2 plus 1. Second one, number of triangles that can be formed using these points is NC3 minus KC3. Second one, if there are m parallel lines intersecting another set of n parallel lines, then the number of parallelograms that can be formed is MC2 into NC2. Why 2 points? Because 2 points make one line. Third one, if a polygon has n sides or n even vertices, then number of diagonals is equals to NC2 minus n is equals to n into n minus 3 divided by 2. Fourth one, relation between NPR and NCR is NPR upon NCR is equals to R factorial. So So students, you do remember the properties of NCR as well as some important formulae. Based on these, we are doing examples. Example, if NC4 is equals to NC5, then find the value of N. So which formula is suitable for this? Chuck from the property, that is from the property of NCR, fourth one. If NCR is equals to NCK, then either R is equals to K or sum of R plus K is equals to N. Simply add R and K, that is 4 plus 5, that is your value of N, which is equals to 9. N value here is R plus K, that is 4 plus 5, which is equals to 9. Similarly, next one, find X if 99C40 plus 99CX, which is equals to 100C59. Here see students, both are higher values. You can reduce the number of R as 99C of 99 minus 40, which is equals to 99C 59, that is almost equal to your RHS part. Now, since we know that NCR plus NCR minus 1 is equals to N plus 1 CR, from the properties of NCR, fifth one, we can compare this with the given formula, that is 99C59 plus 99CX, which is equals to 100C59. Now after comparing this with the previous formula, you get X value is equals to, here R value is 59, 59 minus 1 is 58. The value of X is equal to 58. Next one, if NPR is equals to 3024, NCR is equals to 126. Now find R. So students, I will give you the clue. Here both NPR and NCR is given. To find the value of R, you just divide these two numbers, you will get R factorial value. So you get R factorial is equals to 24. Now since we need to find only R, not R factorial, now find the factorial of this. You get the value of R is equals to, R factorial is equals to 24 can be written as 4 factorial. Then the value of R will be 4. One more example. A person has 9 friends. In how many ways can he invite one or more of them to a dinner? Students, you do remember a person, he is having 9 friends, may call one friend for a party, or 2 friends, 3 friends, or may he call all friends. Therefore, the different ways inviting his friends is equals to 9C1 plus 9C2 plus 9C3 up to 9C9. He may call one friend out of 9, 2 friend out of 9, so on till all the friends he may call for a dinner. Now, this is the formula from the properties of NCR, 7th one. So its right part is 2 raised to 9 minus 1. Here 2 raised to n is equals to 9 friends. Therefore expand it, simplify, you get 511 ways. I hope students are enjoying doing this maths. Next one, important one. There are 12 points in a plane, of which 5 are collinear. Find the number of straight lines, triangles that can be formed by joining these points. Students, Here we are using the formulas of useful sum formulae, that is second part. In this we have discussed it. So first one, they have asked us to find the straight line from 12 points. In that 5 are collinear. So by joining any 2 points we get a straight line, that we know. Therefore out of 12 points, the ways that we can select are in 12 C2 ways. But 5 points are collinear. If both points are selected from these 5 points, they give rise to one single line. So all 5 points make a single line. Therefore, we can write the total number of lines is equals to 12 C2 minus 5 C2 plus 1. Now using the formula NCR, you can find 12 C2, you get 66 minus 10 plus 1, which is equals to 57. Similarly, second one B, by joining any 3 non-collinear points, we get a triangle. But if all 3 points are chosen from 5 collinear points, then we get a straight line, not a triangle. Total number of triangles is equals to 12C3 minus 5C3. So use a proper formula of NCR, that is equals to n factorial upon n minus r factorial into r factorial. You get 12C3 is equals to 220 minus 5C3 is equals to 10. Subtract these two numbers, you get 210. Next one, find the total number of parallelograms that can be formed from a set of 5 parallel lines intersecting another set of 6 parallel lines. So here we are using the formula again. Number of parallelograms is equals to MC2 into NC2, that is equal to, here total number of parallelograms we are finding. Therefore here the value of M is equals to 5, first set of parallel lines M is equals to 5, and another set of parallelograms, parallels are 6. Now substitute these two values in the formula. You get the values as 5C2 is equals to 10 and 6C2 is equals to 15, which is equals to 150. Another important example is find the number of diagonals in a decagon. So a decagon has 10 vertices. By joining any 2 vertices, we get diagonal or side. Hence 10C2 gives us total number of diagonals and sides. Therefore number of diagonals is equals to 10C2 minus 10. 10C2 is nothing but 45 minus 10, which is equals to 35. Next sum, 2 more sums are remaining, students. In how many ways can 6 people be selected out of 12 people so that 2 particular members must be included? B, 2 particular members must be excluded. Here see, out of 12 people we must have to select 6 people. In that, the first question is 2 particular members are always included. So do remember this point and see. So 2 people out of 12 are included means in 12 remove 2, it will be 10. Similarly, already 2 people are selected means in 6 you remove 2. In 12 remove 2 people, also in 6 remove 2 people. You get 10C4 values, which is equals to 210 ways. Second one, two particular members must be excluded. Excluded means remove them. Out of 12, remove the 2 people are rejected. From the remaining 10 people, we have to choose 6 from 10. This can be done in 10C6 ways. That is again equals to 210 ways only. Okay. Next one, a team of 11 is to be chosen from 18 cricketers, of whom 6 are bowlers and 3 are wicket keepers. In how many ways can a team be chosen so that there are exactly 4 bowlers and 1 wicket keeper? B. There are at least 4 bowlers and at least 2 wicket keepers. So read the question again, students. Until you understand, you just go on making the points. There are 11 members in one team of cricket, right? So here the total members are 18, out of which 11 we have to choose. In that, the first condition is there are exactly 4 bowlers. The total number of bowlers here out of 18 are 6. 6 are bowlers, 3 are wicket keepers. So always with the total you have to choose the remaining the conditions. That is, bowlers are 6, wicket keepers are 3 and others are 9. So there are exactly 4 bowlers in the first question. That means out of 6, write down 4 here and 1 wicket keeper. So 4 plus 1 is 5, but we need 11 members. So to make it 11, 4 plus 5 out of 11 we should need 6 more cricketers. So in others you just write it down 6. So 6 plus 4 10, 10 plus 1 is 11. Total should be 11 cricketers. Now the next calculation part is 6C4 into 3C1 into 965. From the total number of bowlers we are selecting 4, therefore it is 6C4 into, out of 3 wicket keepers the selection is only 1, that is 361 into others 9C6. So simplify this using the formula, you will get the total number of ways is equals to 3780. Okay. Similarly for next condition, there are at least 4 bowlers and at least 2 wicket keepers. Whenever students at least will come, it means with the number and till the last number, that is more or equal. At least 4 bowlers means it may be 5 with 4, 5, 6. How many bowlers are there? 6 are there. So 4, 5, 6. 3 possibilities are there in bowlers. Similarly in wicket keepers, they have asked 2 wicket keepers, means we can take 3 also. At least means more also we can choose. Now in others, which will remain here, that we have to retain in the others column. That is, first line you just see 4 bowlers, at least 4 they have told, and at least 2. 4 plus 2 is 6. Then adjust 5 so that it becomes 11. Okay students, 4 bowlers, I am repeating, 4 bowlers and 2 wicket keepers from the statement makes 6 cricketers, and plus 5 makes 11. Okay. Then in the next line, 4 bowlers, and you can take one more wicket keeper. At least 2 is given. You can also include one more wicket keeper. So it becomes 7 totally. 4 plus 3 is 7. 7 plus 4 is 11. So altogether it must be 11 members in a team. Next, in the next step, students, just be careful. Bowlers are out of 6. At least 4 is given. We can take 5 also. 5, then 2 wicket keepers. 5 plus 2 is 7. Then take 4 more players to make it 11. Similarly, 5 bowlers and 3 wicket keepers makes 8, and 8 plus 3 is 11. And we also can take all 6 bowlers. We can include 6 plus 2, 8, 8 plus 3 is 11. Again 6 bowlers, 3 wicket keepers and 2 in others column. So altogether it must be 11. You don't get confused, students. See, bowlers at least 4 is given. So 2 times add on 4 with wicket keepers. One time you change it to 2, another time 3. Then again next line you can increase the number of bowlers 5 to 5. Again wicket keepers with 5 ones with 3 ones. And the last two lines, you can include all the 6 bowlers and one with 2 wicket keepers and one with 3 wicket keepers. Others, based on these 2 numbers, you have to write down their numbers. Add on the numbers. Fine. Now, after this all 6 lines, simplification part. Be careful here. 6 out of 6 bowlers, we are choosing 4. 6C4 into 3 wicket keepers, 3C2 into 9C5. Now write down this one, solve for this. You will get answer as 5670. Similarly, second line, out of 6, n is always 6 here, students, as a bowler, and in next line n is equals to 3, and last column others n is equals to 9. R values are given in the 3 columns respectively. Now simplify in the same way. 6C4 3C3 into 9C4, which is equals to 15 into 1 into 126, which is equals to 1890. Similarly, do calculation for all these 4 lines and add them up. You will get the total number of ways can a team be chosen. That is 10,620 ways. You just see it again and again, and if you think logically, this sum will entertain you. So with this, students, I will conclude with more sums on the same lesson and exercise. I will meet you in the next class. Thank you.